To demonstrate APE behavior of MongoDB, I have used this architecture. So in which there's one VPC in which there are two subnets, and these are my these 5 nodes represents my 5 MongoDB nodes. So these subnets are separated by 2 different ACLs. So using these ACLs, I'll do the network partition between them. I'll stop the traffic between them. So initially I'll induce the primary node amongst these two. The reason behind that is because I want a leader election, new election leader to be happen. So what will happen is, like, once the network partition is there, as the primary is in minority group, so the MongoDB will elect this node will elect a election to hold a new primary, to elect a new primary. So these 3 nodes then will fight against each other to elect a new primary node. So my EC2 setup would be something like this. I have 5. These are the 5 nodes. I have just aliased these names. So the DB node 1 to 5 are my 5 DB nodes. In this, I have induced, as I said earlier. So if this is my DB node 5. So currently this is, I'll do rs.status. So node 5 is my primary, node 4 is secondary, and all other consecutively are in secondary. So 3 are in one subnet and the other 2 are in 4 and 5 are in other subnets. So basically I'll use this database. Now, like, everything is there, so I'll first insert 2 records in a new DB. So this is the first inserted record. And this is the another inserted record. So now these writes in the primary should be synced with the other secondary nodes. So I'll say, like, I'll log into this secondary node. I'll start a Mongo. I'll do a rs.status here. So everything is healthy. I'll use the database Cmpe281 and I'll do not find. So as the default behavior of Mongo is, like, it doesn't allow reads to be read from the slaves, I'll do this command to enable it. Now the find should work. So yeah, so these 2 records are visible. So that is the normal working of the replica set that is being happening. So these 2 records are shown on now slave as well, which was inserted from the primary. Now what I'll do, I'll create a network partition between them. So I'll go in here. These are the 2 records I inserted, which are coffee latte and milk latte. So before inserting it, I'll create a network partition here, so that the basic idea is, like, the default timeout for the election is 10 seconds. So I'll insert these records after just creating after network partition, and in between the 10 seconds, these records will get inserted in my 5th node, which is initial primary. So I'll do that. I'll go to my AWS. Meanwhile, I'll also copy this one. So as I said, this is my subnet which is having 4th and 5th node, and this is my subnet which is having the other 3 nodes. So what I'll do, I'll edit it. This is my IP CIDR block of subnet, the subnet with the 3 IP nodes. So I'll just deny it here. Similarly, on this side, I'll just deny this. On saving these records, the network will be partitioned. So in between the 10 seconds timeout, I need to create 2 records. So I'll just save it. Now I quickly go to the DB node. I'll enter 1 record. and I'll enter another record. So if you see, so these two records are created when there, as it is a asynchronous call, so this is still my primary, even the network partition has happened. So basically black coffee and mocha are created when there is still a partition, when the partition is happened, but still the leader election is not there. So now after 10 seconds have been passed by, what I'll do, I'll go to the other secondary nodes, let's say DB node 1. I'll do a Mongo here. I'll do rs.status to see like what's the new election. So as you see, DB node 5 and 4 are not reachable because I created a network partition here, and see the DB node 2 is my primary now. So currently what DB node 5 have stepped down and DB node 2 is primary and the network is already partitioned. So now what I'll do, I'll go to the DB node 2 and I'll insert some records here. So I'll do rs.status to see. First I'll do a Mongo and see like, right, this is my primary, right? So now I'll use Cmpe281. I'll do a find here. So still the two writes I wrote on after the network partition is not visible here. So that's the one case of stale writes. Now what I'll do, I'll insert the cappuccino and these two records inside it. So now I'll again do the find. So now it has 4 records. 2 were before the network partition and 2 are after the network partition. So so the new primary one has 4 records, whereas if I go to the node 5, which is not a primary anymore, I'll do Mongo here, status, and I'll use that database to find out what's happening here. I'll do a find query here as I did there. Yeah, as I have to override it to override the default behavior of mongoDB. So if you see, so currently the secondary node, that is the 5th node, the earlier primary one before the network partition, is having 4 records. The black, note that the black coffee and the mocha I inserted after the partition, and this is my, in this node 1, in this node 2, the above 2 are the same one in sync with the node 2 because those were the before the partition, but the last 2, cappuccino and espresso, are not in sync with these nodes. So this shows the stale reads while happening in what is happening in network partition. So now what I'll try to do, I'll heal that partition. I'll just again allow the communication between the 2, and let's see like what writes are lost. So milk and coffee latte are in sync, so those will be same, but those last 2 records of each of them, some writes will be lost because again when the all 5 nodes come, so it has to decide like which primary is right, either node 2 in our case or node 2 5 writes are to be written. So I'll go to my ACL, I'll just edit it again, I'll allow traffic here, edit it again, allow traffic here. So yeah, so these are the CIDR blocks both, ACL and this ACL. I have allowed this traffic again, so now the two subnets are talking to each other again. So now let's see like what writes are lost in this whole scenario. I'll do a Mongo here. I'll do a Mongo in. Let's do the rs.status. So now as the partition has healed, you can see like there is no not reachable, everyone is reachable. Node DB node 5 is secondary, 4 is secondary, 3 is secondary, 2 is primary, 1 is secondary. So this is my node 1. I'll do use Cmpe281. I'll again do a find here. Yes, again I have to override the default nature of mongoDB. So this command demonstrates like I'm allowing reads to be happening from the slaves as well, which is the high available feature of Mongo. So I'll do a find here. So now, yeah, so that's in sync with all these 4 records. 2 are like as same as before. The cappuccino and espresso are in sync what the new elected primary was having. But when I'll go to the node 5, I'll do a Mongo here. I'll use Cmpe281 and again do rs.slave OK. So this is my node 5 and this is my node 2. So now as partition has healed, every slaves like the primary and the secondary are in sync. The node 5 was earlier in network partition, but what happened here is like I have lost the 2 writes which I did on the initial primary, and those were these 2, black coffee and mocha. So these 2 are writes, that's the write loss I have incurred while doing a network partition. But as the partition has resolved, everything is in sync. So suppose this is node 4. I'll do a Mongo here. I'll do rs.slave OK, and I'll find I'll do a find here. I need to switch to that DB, Cmpe281. So see, so this records are also in sync with the primary nodes. So now the partition has healed, but I have lost 2 writes that were initially done by my oldest primary, that is black coffee and mocha. Thank you. That's the nature of what mongoDB behaves. But know that it's a piece, because even if the partition is there, I'm able to, no node is not reachable. Everyone is reachable, but yeah, there are stale reads happening. So that's the high AP nature of Mongo that I have demonstrated here. Thank you.